Steve here to answer a trigonometry question. You can see the question up here in the upper right corner. Prove that secant of x divided by cotangent of x plus tan x equals sine x. So first time I read this, I would have liked to see parentheses. So what I did is I rewrote the equation here just to make it clear what's in the numerator, what's in the denominator. Okay, so basically all I'm going to do in the steps that follow is only focus on the left side, and we know that the right side is sine x. That's where we want to go. All right, so before we get started with this, let's make sure we have a good review of what trigonometric formulas and relationships we should have at our disposal. So let's write those down. Secant, what is that? That's 1 over cosine. Cotangent, well, that's just 1 over tangent. And tangent is sine over cosine. So cotangent would be cosine over sine. Another one that's going to be useful for this is you may know sine squared plus cos squared equals 1, but you can use this one as well. This should be in your algebra book or trigonometry book as well. So tan squared plus 1 equals secant squared. Okay, so I like to have those available. So have those trig identities available anytime we do a problem like this. Okay, so the first thing I'm going to do is basically leave the numerator alone. And what is cotangent? Well, cotangent and tan are inverse. So I'm going to basically replace cotangent with 1 over tan x. And I have this. And again, note I'm not writing the right side. Okay, so that actually looks a little bit more difficult. But what I'm going to do now is in the denominator, focus on the denominator, leave the numerator the same. And now I'm going to get a common denominator in the denominator, right? So I'm going to write tan of x here. So 1 over tan of x is here, but then what do I need to do to put tan x over here is I have to square this. So tan squared x over tan x would get us back to here. So all I'm doing is this. Now, why am I doing this? Well, notice here 1 plus tan squared equals secant squared, and then I have a secant over secant squared. So that's basically why I'm doing that, okay? And so I'm just rewriting this. So first what I'm doing is, putting tan in the numerator. So I have secant times tan divided by this 1 plus tan squared. And I've already kind of alluded to the fact that 1 plus tan squared is secant squared. So now what I can do is divide these. And so I eliminate the secant in the numerator, and I'm just left with 1 secant in the denominator. So that will leave me with tan over secant. Now, what is tangent? Again, tangent is sine over cosine, so I'm replacing the tangent here. And just to be clear, let me do that cancellation for you. So notice I have this secant here and this squared that I'm getting rid of. So I'm left with tan x over secant x. And then so what is tan x? Tan x is sine over cosine. And what is secant? 1 over cosine right here. Okay, so that's basically what I wanted to show with that step. But now, when I look at this, I could basically multiply top and bottom by cosine of x, which is 1. So if I do that, notice the bottom will cancel. And this sine x over cosine times cosine leaves me with, lo and behold, sine, which is exactly what we are trying to find right there. So again, my approach for these problems, step 1, really have these identified, have those available. Now, could I have done this many different ways? Of course, right? I could have done a direct substitution of secant and cotan and tan just in terms of sine and cosines and use sine squared plus cos squared equals 1. There could be other methods as well. So this is just one approach I took, and see if it makes sense. Thank you for your time.